Hey, this video here that I'm going to show you, this basically shows you how to break a task down into three parts, so you can break up your task into three parts that your team can work on as three different groups independently. And I can tell you that I shot this video about 2 weeks ago here at home, and then last week with our FLL team we actually implemented this, and I was able to get a group of grade 5 and 6 students to be able to complete the filter mission in a little over an hour. So this video showing me doing this, but I was able to implement this with some fairly young students doing this as well. So good luck and give this a try. Thanks. Okay, so what we're going to try to do here is show how to break up your team into smaller groups to keep everybody busy and have them work on completing a mission or two. So what I have here to do this, I have last year's Animal Allies mat laid out. I don't have the models on it, so I've basically put some game boxes on here and a mug to basically make obstacles where I'm not allowed to drive. That's where there was models last year. And I've got my basic robot that has basically just two motors, no sensors, and I got two game pieces. I've got the pig, or the pet as it's called, and I've got the seal with the camera on it way over there. So the two missions we're going to do here, the other two things I have a pen and some paper, and I have a tape measure. So one of the big challenges you have with your team is how do you break up your team into groups and keep everybody engaged and everybody doing something so nobody's left out and everybody has something to work on. So I'm going to show you how you can basically break up a mission into three individual tasks to keep everybody busy. So the two missions I'm going to try to do here, I'm going to show taking the pet. We're going to assume that he's already been retrieved. So he needs to travel from here and end up over here inside that area, which is the farm. The second thing that needs to happen is get over to the seal, grab the camera off the seal, and return the camera to base. So this is pretty typical for some missions. I would call the pet, I would call that a pushing type mission. Basically you're going to push or transport something to a location, and then so that could be similar to the wishing well or the sludge in the hydrodynamics game. And this one here with the seal, camera on the seal, that is a grab something, pick it up, bring it back mission. That could be the same as the pipe replacement, or the pipe removal, very similar to the pipe replacement as well in the hydrodynamics game this year. So show you how I'm going to go about accomplishing this. Okay, so here's what we're going to do. We're going to basically have builders, planners, and programmers. So the builders, they need to build two attachments for this. So the attachments are basically going to go on the front of the robot or wherever they need to go. This robot has very poor mounting areas, but basically you can attach here, here, anywhere on the side, wherever we need to attach something. So they basically need to build two attachments. One is going to be something that's going to look kind of like a snowplow probably for pushing the pig. The second one is going to something that actually needs to move. There's going to be some kind of a fork or something like that that's going to be used to pick up the camera. So I'm going to tell my team, whoever's doing the building, that is what they need to build. Now they can know that, for example, pushing the pig, the robot is going to end up here, there, and if the robot is there, if the other rest of the team can get the robot there, your attachment has to be able to push the pig into that area there. So your attachment basically needs to be here, come down, grab the pig, and push it along. Same with the seal. If I can get the robot here, I need to have something that is going to pick up that camera if the rest of my team can get the robot here. That is the role of the builders. Okay, so here's what we're going to do for the planners. So they're going to figure out how do we navigate and plan out what these paths are. So they need to draw this out on paper, and then they need to go back and measure and figure out what all these things need to be. So for the pig, we're going to start in base. We're going to drive forward, make a left turn at some angle, drive forward again to there, make a right turn and drive forward, stop, and then basically repeat all those steps backwards to get back to base. Basically drawing that path, what the planners will then need to do is figure out how long are each of those moves in millimeters and what are the angles that we need to turn at to make that work. Now I can tell you we did the pig mission last year with our team. That was probably the furthest that we traveled on the board last year. We did not do the seal mission. We could not get over there reliably. And as you can see, that is a much more complicated path to get to there, because you have to go in between that narrow gap there, adjust some more angles, and get over there to where that is. So we are going to plan that one out. That is a much more complicated path, and that's probably more complex than anything that's going on in the hydrodynamics board this year. Last year's Animal Allies board, much more cluttered than the hydrodynamics board seems to be. So the next step for the planners is they need to figure out angles and millimeters, and they can get working on that. Okay, so we're going to start our programming. So at this point, programmers have a general idea of what needs to be done, but they really don't know any specifics about it. But they can start getting on a computer, and in our group we have a limited number of computers. So the programmers can start making a program where they're going to fill in the details of it later, but they can start making the rough outline of a program. The way they can do that is to start laying out some comment instructions here to give a general outline of what their program needs to do. So I'm going to use these comment blocks, and I'm basically going to cut and paste them. So the general idea of what this program needs to do, I'm going to start here, and I'm going to say it's going to start at home base. And then it's going to drive to the farm. It's going to drop off pig. And then return to home base. So this is a pretty good method to go through whenever you have people on your team programming, because if they can logically lay out what they want their program to do, they should be able to go back in later and actually code each of these portions. So if they know how to drive to the farm and they know how to return to base, but they don't know the process for what they actually need to drop off the pig, they should still be able to code the drive to the farm portion. And they can start coding that without needing to understand everything that needs to go on in the program at one time. So they shouldn't be held up from programming just because they don't know how to do one particular part of the programming. They can still do chunks of it. And they can just leave those other pieces they don't know how to do yet, they can just leave those out for this point. They can still program and experiment with the rest of it, and then just leave some placeholders in there for things they need to fill in later. Now, once the planners have laid out what needs to be done specifically, they can start to add those things in. So if we look at what the planners were doing, we know that they had to do some basically driving for a set number of millimeters and then turning for set numbers of degrees. And we can accomplish all those by using our My blocks we have developed. So to start at the home base, then we're going to drive to the farm. We can just leave these comments right in here for now. So we're going to drive basically by the flowchart we've developed. We know that we're going to drive forward for a certain number of millimeters, make a left-hand turn, drive forward again, then make a right-hand turn, and then drive forward again. And that's going to take us to dropping off the pig. Once you get to the end of a line here, I like to do this to keep my program easier to follow. I can now just draw a wire here, connect this together. That's doing the same thing. Just makes my program easier to follow. So I know the basic motions that are going on here. So my coders, they can, or programmers, they can fill all these things in. And I know that my return to base motion, my drop off pig really doesn't do anything, that just is dropping it off. This here is essentially all the same motions, just going in the reverse order. So that's essentially what my program is going to look like. Now I just need distances, speeds, and angles for all of these. I know that my speeds, just to be simple, we're going to make all these 20. You can figure out what works for you. But I'm just going to make all these 20. Now I'm waiting for the rest of my team, as my coders are working on this. They are figuring out with a tape measure and something that can measure angles or estimate angles what all of these actual values need to be. So now my team has come back. Okay, so my pig program, my programmers can basically write that out into a chart form like this for the pig program. Basically we know that my steps of my program are basically going to be move forward, turn left, move forward, turn right, move backwards, turn left, move backwards, turn right, move backwards. So forward, left, forward, right, forward. I made a mistake there. There should be another forward in there. Backwards. That's a left turn, backwards, right turn, backwards. That takes me right back to home. So they can go ahead and start coding this. I'll show you what we're going to do there. And it's up to my planners at this point to figure out what values are going to go in those coding blocks. So right now I should have 3 teams all working independently. I've got someone on a computer that's figuring out some coding. I got someone that's measuring, figuring out what this path actually physically looks like. And I got someone that should be building an attachment to put on there. .45-degree angle. Okay, so now we know our values based off of what our planners figured out. They came back and they said we are going to go forward 600 millimeters. We're going to turn left by 45, so that is going to be a negative 45, the way this block works. We're going to go forward 500. We're going to go right 45. We're going to go forward 200. I'm actually doing this second time through. Now, I did not record this the first time I programmed this, so I'm programming it again. This is going to be a negative 200. I did this incorrectly the first time I programmed this. I put in a 200 and it went forward instead of backwards, so the negative 200 means it's going to go backwards because I'm doing my return to base. I don't have video of that, but it basically went the wrong way after it did the drop off the first time through. Then this is going to be a left turn on the way back, so that is a negative 45. This is going to be a negative 500. This is going to be a 45 to do a right turn. And this is going to be a negative 600. And that should be my program that should work. This is my attachment. You can tell, pretty simple. And with attachments, this is pretty crude, but you want to have something you can easily put on and take off. You need to be able to do it quick in competition. This is not a good robot for attachments, but there we go. So there is a little pushing device. So hopefully that will push the pig where I need to go. Okay, so we've got our spot marked where our wheel is. We want to make sure when we're testing here, we always start from the same spot. And definitely when you're running your missions, you want to start from the same spot. So that's where we're trying to get to. Let's see how we do. Here we go. That's going to hit the cup. Okay. And we're going to stop there. So basically what we learned there was that first distance, which was 600 millimeters, we need to make our turns sooner than that. So we'll change that to 550 and see what happens. Okay, so we saw here we had some problems there. So our next step is to basically go through and edit our program to make some fixes. We're going to try to fix that first motion. We're going to turn earlier, so we're going to change this to 500. Change this last motion to negative 500. And try that again. And we can either be changing these. We should also be keeping a record of this on our papers as well. So we're going to download and run this. See how it. All right, several tries, but I think I have some good numbers here. Running. See how we do. End up back in home base. So that is basically one completed mission. You need to tweak this a little bit because that guy needs to be completely in the farm area, not touching the lines. So that needs to be more like over here. Score full points, but that's a pretty good start. And the program itself pretty simple. It's just a matter of getting the right values in there, and those were just doing some adjustments after the fact. So that is kind of showing how you can take a multi stage task, break it up into 3 parts. Going back to our sheet here, builders, planners, and programmers. Everybody does their part. Everybody can work independently, come together at the end when it's all ready, do your testing, and you should have a completed mission. And hopefully you can follow this strategy for all of the missions. Okay, so good luck, and we'll see you next time.